So that's the song. You're welcome to go on YouTube and look it up anytime. Khalees, what's up?
I'll do it right now. The ambiance.
Later? No, you'll have time. Do it now. Okay, so we are going to talk through slope, rate of change, all these things. You got to lock it up right now. I'm recording. I was going to hear you say record. So rate of change, okay? The rate of change is going to be a very big focal point of what we do in this chapter. It is the relationship between two changing quantities. So how much did you rise and how much did you run? We'll get to that in just a minute. But it is the change in your dependent variable over the change in the independent variable. Do you remember which variable is dependent?
Y.
Y is dependent. So this is the change in Y over the change in X. Okay, so how much your Y changes by divided by how much your X changes by. That's your rate of change. If you look at this first example, they give you a table. It says the table shows the distance a band marches over time. So distance and time. Remember we said time is typically our X. Is the rate of change in distance with respect to time constant? What does it mean for something to be constant?
Stays the same.
Stays the same, unchanging, right? So is this constant in their rate of change? Do you know how you can figure that out?
We can add it.
We said this change in the dependent divided by change in the independent. What is the change in our Y value right here? 260. Right? 260 plus 260 is 520. What's the change in your X? 1. If you subtract those, it's 1. What's the change from the second to the third? 260. What's the change over here? 1. What's the change here? 260. What's the change here? So it's the change in your Y value over the change in your X value. So it's 260 feet per what? 1 minute. Okay? Because it was 260 over 1 every single time, is your rate constant?
Yeah.
Yes, that is a constant rate of change. So the answer to this one is yes. And we would say it's 260 feet per minute that the band is marching. Okay, every minute they march another 260 feet. Does that make sense? Okay, so that is all related to slope. A rate of change is a slope. And if you've heard of slope before, which I'm assuming all of you have in some way, shape, or form, there's a lot of ways to think of it. It's your vertical change over your horizontal change, or it's your rise over your run. Rise meaning I can go up or down, but here's the thing. The run should always go from left to right, okay? Always left to right. Could you find it going right to left? Yes, but then you have to flip the other part of it too, and it just is a bad practice because people make silly mistakes. So here's my advice to you, my request for you is when you find slope, you do your rise either up or down, but you always move from left to right. So I start at a point and I move to the left to get to my next point. If that means I have to go down, then go down and to the right. If it means I have to go up, then go up and to the right. Okay, so take a look at these first few. If I want to find the slope of these lines, I go as far to the left as I can. In this one, they gave us 2 points. So here's your 2 points. My point to the left is the circled one. That's where I want to start. To find the slope, I'm going to go rise. So I went up 2, that's a positive 2, and then run 1, 2, 3, a positive 3. That means my slope is the rise over the run. So we have a slope of 2/3. Okay. So what is it going to be for B? -4 over 5, right? I start at the point on the left. Here's my 2 points. The one on the left is 1, 2, 3, 4 down. That's a negative 4. Always to the right. 1, 2, 3, 4, 5. So negative 4 over 5. Okay, this one requires an extra step a little bit. Look at the 2 points they give you. Here's a point. Here's a point. Which point are we going to start from? The one on the left. Okay, always start at the one on the left. So if I'm starting here, do I need to move up or down? Down. So we're going to go 1, 2 down is a negative 2. And then 1, 2, 3, 4, 5, 6 is a positive 6. Your bottom number is always going to be positive if you do my method. Okay? So down 2 over 6. What can you do to that? Reduce. If you can reduce, you should reduce. So the slope here is a negative 1/3. Okay? God bless you. All right, last one. Which point are you going to start at? The one on the left. You're going to start here. Where do we move? Up or down first. So we're going to go up. 1, 2 up. And then 1, 2, 3, 4, 5 to the right. So what is your slope?
2, 5.
It's not 2, 5. What is that?
2 over 5.
2 over 5 or 2/5 or however you want to think about that. Maybe the most common thing I see done wrong here is people trying to turn it into a point. It is not a point, right? It is 2 over 5. The change in your y value over the change in your x value. Henry.
Where's 5, 2? So there's 5, 1, 5, 3, A.
We skip 5, 2. Yeah, we're not going to do 5, 2. It's direct variation, and we cover that in more depth in Algebra 2, and we had to cut a few things just to make sure we get to what we want to get to, and that's one of the things we cut, so. Yep. Okay, so we said rise over run, right? The rise over the run. The other way you can think of it is as a formula for slope, and the formula for slope, it's right here, but I'm just going to rewrite it. It is your y2 minus your y1 over your x2 minus your x1. It's the change in your y value over the change in your x value. Okay? Now, this gets done wrong a lot, and it is not hard. It is just that you have to take your time and pay attention to your numbers, because inevitably people rush through it and then they use a number that they didn't think actually needed to be the number, but they just rushed and used it anyway. So here's what I need you to see. If you are given 2 points, like you see in example 3 here, if I were you, I would label those every single time, okay? A point, right? If I write a point, what goes here? X. What goes here? The Y. Every time. You will never have a point that is an X and an X. You will never have a point that is a Y and a Y. But some of you are going to pretend that you do. Don't do it, okay? Here's what I would do if I were you. I would call this my X1, which would make this my Y1, okay? So it's my first point. That's where the ones are coming in. And you have an X and a Y. What do you suppose you call the 3? X2, and the negative 2? Y2, okay? I know that feels silly to write them down because you know you have an X and a Y, but some of you are going to mix them up. It happens all the time, okay? Write it down. X1, Y1, X2, Y2. So if the slope formula is Y2 minus Y1 over X2 minus X1, and I tell you to find the slope, you're taking those things you just labeled and you're dropping them into that formula. What is Y2? Negative 2 minus what? 0, your Y1. So negative 2 minus 0 is your Y2 minus your Y1. What's X2 minus X1?
Negative 1 minus 3.
No.
3
Oh,
negative.
sorry.
3 minus a negative 1. And be careful with negatives here. The formula is subtraction. So if you're subtracting a negative, you're actually doing what? You're actually adding. Minus a negative is plus a positive. Okay, so negative 2 minus 0 is negative 2. 3 minus a negative 1 is 3 plus 1, which is 4. Is that your slope?
Sure. 1/2.
Not quite.
Negative 1/2.
Negative 1/2. If you can reduce, you should reduce. Okay, so the slope of the line that goes through those 2 points is a negative 1/2. Okay, using that idea, labeling your points, you do letter B. Identify what is x1, what is y1, what is x2, what is y2, and then plug it into the slope formula, and let's see what you get. Oh. More music. Sorry. Okay, so first of all, tell me what you called this one. X1. What if I called it X2? So I would call this X1, but what if I called it X2? Is that okay?
Sure.
It totally is. But if that is X2, then what's the 3? Y2, okay? So it doesn't matter if the first point you see is your X1, Y1, or if the second point is your X1, Y1, but you have to keep your 1s together and you have to keep your 2s together, okay? So let's just call this X1. Then what is the 3 going to be? Y1, right? So it's X and a Y, X and a Y, X and a Y for every point. So what's the 4? X2, and the negative 1, Y2. Okay, we'll plug it in a minute. What did you get for your final answer? What is the slope of the line that goes through those 2 points? Negative 4. Negative 3? Positive 3, right? Okay, so let's lay it out. Y2 minus Y1 over X2 minus X1. This will be your slope. M is usually the letter associated with slope. We'll get more into that in a couple days. So Y2 minus Y1 is a negative 1 minus 3. X2 minus X1 is 4 minus 1. So you get on top a negative 4, on bottom a positive 3. So that's a negative 4 over 3. Okay. Don't turn that into negative 1 1/3 because slope is always rise and run. So to have a whole number out in front doesn't work when you're trying to actually do the slope. So just leave it as an improper fraction. Don't turn it into a decimal. Just leave it as a fraction. Questions on how you find the slope? Okay, most important thing with slope is that you know what your x1, y1 and your x2, y2 are so that you can plug it into the formula. All right, take a look at this. Do you know what kind of line this is called? Is that horizontal or vertical?
Horizontal.
That's horizontal, okay? Which is half the battle if you can figure out which one is which. This one's the vertical, okay? Vertical is like this. Remember, horizontal, you look out on the horizon. Do you know what a horizon is? Yeah, where the ocean meets the sky, right? Horizon, horizontal. Or the land meets the sky if you're not by the ocean. So if we're using the idea of slope, and we want to know the slope of a horizontal line, you have a couple options. What? You could use the points that we have there and plug it into the slope formula. So if I call this x1, y1 and x2, y2, it would be y2, which is 2, minus y1, which is 2, over x2, which is 2, too many 2's in this problem, minus your x1, which is a negative 3. When you simplify that, 2 minus 2 is 0. 2 plus 3 is 5. What's 0 divided by 5? It's 0. You're allowed to divide a 0 into 0 groups. So that is 0, okay? That will be the case for every single horizontal line. The slope will always be 0. Here's how I always tell people you could remember this. The word horizontal, right, has a slope of 0. Horizontal. The O is a 0. Anyone know the slope of a vertical line?
1.
It's not 1.
0, 3. 10.
It's a weird word. It's undefined, okay? Or you say no slope. Here's how you do. If this is x1, y1, and x2, y2, you would go y2 minus y1 over x2 minus x1. Okay, look what happens. Negative 2 minus 1 is negative 3. What's negative 2 plus 2? 0. Plug that into your calculator. Negative 3 divided by 0. Plug it in.
0.
Plug it in.
Syntax error.
Did you plug it in?
Syntax error.
Plug it into your calculator. What's negative 3 divided by 0?
404.
0. Divided by 0 error.
Mm-hmm. It says something like divided by 0 error, right? You cannot divide something by 0. So we say that slope is undefined, or you could say it has no slope. Okay, that would be the same thing as undefined. Here's the thing though. People are tempted to call this no slope. This is a 0 slope. 0 slope and no slope are not the same thing. So I don't love the no slope. I would prefer you call this one 0 and you call this one undefined. That just helps you keep them a little more straight, which one's which. But if you say no slope, that's okay. This is no slope or an undefined slope, okay? Okay, so here's what I want you to do. I want you to find the slope of C and D right now. Plug those into the slope form.
He said he did it in the last. Oh, he's bored.
Do you have a slope? What'd you get for C?
0.
Undefined. So if this is x1, y1, and x2, y2, right? You're going y2 minus y1 over x2 minus x1. So 2 plus 3 is 5. 4 minus 4 is 0. What is 5 divided by 0? It's undefined. It's an error if you plug that in, right? So this is undefined.
Wait, can't you kind of already notice it because like you can.
Right, if your x's are the same. Totally. So then what do you notice about this one? The y's are the same. So this one, x1, y1, and x2, y2. So you're going y2 minus y1. Be careful with that, okay? You're subtracting, but it's a negative. Don't just ditch one of those minuses or negatives. It's minus a negative 3 over 5 minus a negative 1. So this is plus a positive, this is plus a positive. So on top, negative 3 plus 3 is 0. 5 plus 1 is 6. What's 0 divided by 6?
0.
It's 0. If you don't know, plug it into your calculator. Your calculator will tell you if it's an error. If it's an error, it's undefined. If it's not an error, it's that number, which is going to be 0. Okay? So slope there is 0. Slope of C is undefined. Okay, so here's just a slope overview, the pieces of slope that come into play. If a line is on its way up from left to right, that is a positive slope, okay? If a line is on its way down from left to right, that is a negative slope. If it is horizontal, that is 0 slope. And if it is vertical, that is undefined, okay? Any questions on that? This really shouldn't be completely new. Like, I feel like you've done this in previous math classes at some point, yes? Yes. This should just be recap to get us to what we're doing next, but hopefully it's not brand new.